Anybody have any idea why my camera's doing this weird silhouette thing? Or can you guys actually see my face? I just look like a shadow to me.
Yeah, you just look like a shadow to us too, I think.
Well, can you guys at least see my screen okay? All right.
Yeah.
I'll have to figure out the camera thing later. Couple things. I'm going to try and get exam 3 graded, chapter 5 exam graded soon. And then with that, I'm going to try and put up what's your current score type of thing into Canvas somewhere for you guys. You can kind of calculate that yourself as well. Just every section's worth 10 points, except for the chapter 1 stuff, which are up to 2 bonus points. And then exams are worth exam points and so on, and just take your total points divided by the total possible points at this point in the semester, and that'd be what your current score is, if that makes sense. Do you want me to give a little lecture on 6.2 stuff, or do you guys feel like we did okay with the examples from 6.1 and just need to do some more problems?
I think the second option would be good.
Okay. So let me just talk through this one real quick. We're rotating around the x-axis, and so the rectangle is parallel to the axis of rotation, which makes this a shell, right? And because these are rectangles that are stacking up in the y direction, everything's going to have to be in terms of y, which is good because these two expressions are already in terms of y. And so for this setup, this thing rotated here. Drawn in a rectangle. I'm going to label the top and the bottom of it. This is at y. Or sorry, this is at 0, y. And this one's at 4y squared, y. And this is it. Y equals the square root of 6. This is it. 0, 0. So I'm going to do shells. right? And the height is going to be the length of the rectangle, or of the representative rectangle. And that's going to be the change in the x values, right? Because this is horizontal, it's this x value minus this x value. So this is equal to 4y squared. The radius is how far the strip is from the axis of rotation. The axis of rotation is the x-axis, so the radius is just y. And so the volume of one of these shells um, 2 pi r h, and then dy, because these stack up in the y direction. So that's 2 pi r y times 4y squared dy. And then the volume of the whole thing be the integral from 0, and then I go up to the square root of 6 because that's the last place I get one of these shells. And then I put in the 2 pi times 4y and then cubed dy. Simplifies a little bit more. I'm going to factor out the 8 pi 0 square root of 6 y cubed dy. So it'll be 8 pi times y to the 4th over 4, evaluated at 0 and square root of 6. That becomes 2 pi times the square root of 6 to the 4th. At 0, it's 0, so this is 72 pi. Sorry. Where do we have questions on that one? Okay. Were there ones that you specifically want to talk about?
13 possibly.
13. Okay. And this one's shells for all of these. Okay. Oh, yeah, that's fine because all of these are horizontal lines. Okay. So if you had vertical lines, you might have to do a washers or something instead, but we've got horizontal lines, so shells is fine. Okay. So let's draw in a representative strip. Okay. This is going to be at y to the 4th over 4 minus y squared over 2 comma y. This point's at y squared over 2 comma y. We good with my labeling those 2 points there at the end of the strip?
Yeah.
And now for A, we want to rotate around the x-axis, which is at the line y equals 0. Okay. So my radius is, well, it's the change in the y values. So that's going to be y minus the y on the axis of rotation is 0. So our radius is going to be y minus 0. Height of the shell is the change in the x values. So that's going to be y squared over 2 minus y to the 4th over 4 minus y squared over 2, which would be y squared minus y to the 4th over 4. And so our integral for this volume, I get these strips, I start getting them at 0, I stop getting them at 2. I've got 2 pi times the radius times the height. So the radius is y, the height is y squared minus y to the 4th over 4 dy. Are we okay with that?
Why is it from 0 to 2?
So I get strips starting at 0, right? And then I stop getting them when I get to 2.
Okay.
Other questions about the setup? And then I distribute the y inside and then do 2 integrals. I'm not going to do that. Let's do the setup for the next one though. Okay. So the next one has us take the line at y equals 2. So our axis of rotation is up here this time. Does that red show up okay for you guys? Okay. So we're going to rotate around there. So my new radius is this distance. And that new radius is going to be r equals, well, the y value up here is at 2 minus the y value of the strip is y. So 2 minus y is my new radius. The height of the strips are the same, but I just have a different radius. You okay with that? So the integral for this one still going to integrate from 0 to 2 because that's where my strips are. It's going to be 2 pi times r, which in this case is 2 minus y. And then the height of the strips is still the same, y squared minus y to the 4th over 4 dy. Good with that?
Yeah.
Okay. And then similar ideas, if I rotate around the line y equals 3, see y equals 3 is up here another step, right? My radius there would be 3 minus y, because the y value up here is at 3. And the y value here, the difference in the y values is going to be 3 minus y. So I just put a 3 in there, and that give me the volume of rotation around that line. And then if I was, see if I can find another color. Purple might work. If I'm down here at y equals minus 7/8, well, the radius here is going to be y minus 7/8. So the radius would be y plus 7/8. So my integral is going to be 0 to 2, 2 pi, y plus 7/8, y to the second minus y to the fourth over 4 dy. That purple might not show up great, but are we kind of good with how to set these up with different axes of rotation?
Yeah.
Sorry. Do you want me to try and find the actual integrals, or man? Sorry, that cough just not going away today.
No, it's okay.
Other problems you guys want to look at?
On number 8, I can't figure out how to take the actual integral, or like
Okay.
how to like differentiate it, or not differentiate it. Like evaluate it, because it seems, I think, unless I set it up wrong, there's like an x times a sine of x.
Okay. Let's look at this. I'm going to do this by revolving around the y-axis. And does this want washers or shells? It doesn't really say, but we're probably going to do shells because trying to find horizontal strips seems difficult. Okay. I'm going to draw in a vertical strip, and I'm going to draw in a horizontal strip, and I'll show you why the horizontal strips are harder to work with here. Vertical strips, this is at x comma 0, this is at x comma sine of x over x, right? The horizontal strip, this would be at 0 comma y, which is just fine, and this one would be at something comma y. But what I would need there is I have y equals sine of x over x. I would need to figure out what x is in terms of y here, and I don't know how to solve for x in this situation because x is inside the sine function and it's outside of the sine function. I can't really solve for x that way very easily, so this is hard because we can't solve for x. In that situation. So we don't want to use the horizontal strips. So I'm going to get rid of it. Okay, we're going to use the vertical strips, and let's walk through this first part of the problem. We want to know that x times f of x equals the sine of x for all x, including at 0. Okay. Well, not at 0. The sine of x over x is defined, and then x times that would cancel the x's and you get the sine. So that's great. At x equals 0, x of 1, sorry, f of 1 is 1, or sorry, f of 0 is 1, and 0 times 1 is 0, so that works too. It looks like a to me. You get this thing is piecewise defined. You have to figure out why when you do this x times f of x, on this piecewise defined function f of x, that it works out for us. So we have to check both pieces. And in the first part, we check the first piece, and the second part, we check the second piece, and they both worked out for us. So it's true all over. So I'd go with that one. F of x is 1, f of x is 1. What's the difference in the statement here for C? Oh, that says equals 1. But sine of 0 is not 1, so that one's false. Sine of 0 is 0. We want this one. Okay. Next part. We want to find the volume. So let's take these shells. My radius. Of the shell is that. The height of the shell is this. So I want 2 pi r h dx in this case, because these things are stacking up in the x direction now. You're going to integrate from x equals 0 to pi. And so this is going to be the integral 0 to pi of 2 pi. The radius is the difference in the x values. And this is at 0, so this is a radius equals x. And the height is a sine of x over x, because it's the difference in the y value. So it's 2 pi x sine of x over x dx. So those cancel, right? Did you have a squared there on the radius maybe? We don't
No,
need
for
a
some reason I
square.
wrote.
Yeah, we don't need a squared there because this isn't a disk, it's a shell. Does that make sense?
Yes. It's going to turn into the cosine minus cosine. Which I believe turns into 4 pi if I evaluate it correctly real quick in my head. So questions on that one? Okay, other questions you have this one?
11.
Was this all shells or were there washers too, discs?
I just had one that I need help with disk after this too.
Okay,
Or
I didn't realize we hadn't done any disc stuff yet, so I was thinking. Square root of x, y equals 0, that's the x-axis. Y equals x minus 2. Okay, so I've got this guy. And we want to revolve this around the x-axis. And it wants us to use shells. I don't like that. I'd much rather use, well, it doesn't even, okay, shells is fine. Okay, so let's actually get the region here. We're bounded by the x-axis as well because the y equals 0. So this is the region that we're rotating. To get a shell, what I have to do is I have to draw in a strip that's parallel to the axis of rotation, right? So the representative rectangle that I draw in is this guy. This side is at, well, I want everything in terms of y. So x in terms of y is y plus 2 here, comma y. Because if I solve for y, x here, I just move the plus 2 over to the other side. So I get y plus 2 comma y. On this side to get x. To get x in terms of y, I just square both sides. So I get a y squared comma y is this point. My radius is y, because how far away from the y-axis or the x-axis is just the y value. And then the height is going to be this x value minus this x value. So that's going to be y plus 2 minus y squared. So my integral, where they're going to start here at 0. And I need to figure out where this is. To do that, I need to figure out what this point is. So I'm going to set these points equal, these two equations equal. So I'm going to get the square root of x equals x minus 2 and solve that. Well, just thinking about it a little bit, if I put 4 in there, the square root of 4 is 2 and 4 minus 2 is 2. So 4 is one solution, 0 is my, minus 2 is my other solution. For some reason, that's not true. There is no other solution, right? That's the only place they cross. Down here, it's a different line that crosses. Okay. So 4. And it's going to be 2 comma 4. No, 4 comma 2. So this is going to go up to 4. Jeez. Let's be careful about this. I solved this is equal to x. So 4 comma 2. I'm stacking up the y values. So from y equals 0 up until y equals 2. I've got shells, so I've got 2 pi times the radius, which is y, times the height, which is y plus 2 minus y squared, dy. So this is going to be 2 pi, integral 0 to 2. I factor out the 2 pi. I've got a y squared plus 2y minus y cubed dy. Are we good on the setup?
Yeah.
Okay. So where are we guys, are we having trouble with these setups at all? It's just take some practice and
Yeah.
Could you explain? Oh, sorry.
Go ahead.
Could you explain where the y plus 2 minus y squared came from again? Just the height.
So the height of this shell, right? Right, my shell here is like that shape right there. But the height of it is the length of that strip. And that strip is a change in the x values, right? So I'm going to take the big X value, which is y plus 2, minus the little y value, which is y squared. So you get y plus 2 minus y squared. That's how long this strip is. Does that help?
Yeah, okay, yeah.
Okay, I'm not going to actually do that integration. That's not too bad though. So good on this one setup.
Yeah.
Are we kind of seeing how these setups work? I do want to label the entire point on these strips, right? That way I can figure out, okay, do I need to take the difference in the X values? Do I have to take the difference in the Y values? Those coordinates are going to tell you how to find the radius, how to find the height, how to find all that stuff that's related to these volumes of rotation. Knowing if you want them in terms of X or in terms of Y is also helpful. If it's a vertical strip, you're going to have a dx stacking everything up. So you're going to want everything in terms of X. If it's a horizontal strip, they're going to stack up dy. So you want everything in terms of Y. Other questions?
On number 16, one of the sides I'm getting like for like my integration, it doesn't seem it looks like it's kind of like an asymptote along the 0. I was just wondering how you could like go up to that point, like having the top of the integration thing be infinity. Is that possible or?
Well, yeah. Eventually, you'll learn that in Calc 2 for sure. Like 0 to infinity, you can do that type of stuff. You just have to do it with limits. So this is like the limit as b goes to infinity of the integral from 0 to b f of x dx. So if you can evaluate this algebraically, you can get some expression in terms of b, and then you can take a limit of that expression. And if you had like an asymptote, maybe you have a vertical asymptote here at a, and you wanted to take the integral from a to b of say f of x dx, well, you do the same sort of thing. You take the limit as, I'm going to call it c, as it goes to a of the integral from c to b, f of x dx. So you use limits to get, so I can't actually plug in at a because I've got an asymptote there, but I can get close to it and then see what happens as I get infinitely close by using a limit. And so this one, 16, has an asymptote at 0, and 1 over 216 is really close to 0. And so this is just getting you thinking about this type of limit stuff, which you'll see in Calc 2 later in section 6. I think it's like 6.5 maybe. We can, yeah, start reviewing for the final tomorrow. You guys have videos from the entire semester too, to look through if you want, if there's something. But if you do have specific questions, let me know. Was that enough about this one, Matt?
Well, what would I put for that top of the integration thing?
Oh, okay. So on this one, curve looks like this, line x equals. And it's bounded below by the line y equals 1. So we're looking at this guy, right? And we want to find the volume first with the washer method. And we're rotating this around the x-axis. So to get washers, I have to have vertical strips. And they're going to start here at x equals 1 over 216, and they're going to end here at whatever this point is. So I have to figure out what this point is. Well, if I put y equals 1, I would have gotten x with 1. So this point's at 1, 1. So I'd put a 1 up here. Does that make sense? You stack up in the x direction to get me washers. This is going to be an outside radius, inside radius thing. So this is going to be a pi. Outside radius is the 1 over the cube root function. So the outside radius squared is 1 over cube root of x, but I want to square it, so I'm going to put a squared there. And I'm going to take away the inside radius. The inside radius is 1 squared, so I get that. Does this make sense?
Yep. Yeah.
Okay. I'm not going to do that part. But yeah, you have to find this point to figure out where they start and stop. Up here, I need this other point, right? And so I need 1 over 216 to equal 1 over, x is 1 over 216. So 1 over the cube root of 1 over 216, that's equal to 6. So this is at 1 over 216, comma 6. That's my other point. And so for my horizontal strips, which is going to give me shells, they're going to start here at 1 and they're going to end at 6. So I'd have something like the integral from 1 to 6. The shells, they're going to have 2 pi. The radius is going to be y. And the height is going to be, well, if I solve this for y, I get 1 over y cubed equals x. So 1 over y cubed minus 1 over 216, because that's how wide those shells are, and then dy. So that's the other setup. Okay, questions on that? Sorry, questions on that one? Other questions you guys have?
I'm kind of confused on 14.
You got a triangle, a vertex at 2, 2, 2, 8, and 4, 8. That's a slope of 3. And so minus 4, 3x minus 4 is that line. Okay, so we got everything labeled. All the sides are labeled, all the corners are labeled. We want to rotate A around the x-axis. Okay. So let's well, we can pick strips. We can pick discs, washers, or yes, washers, not discs. Well, we can pick washers or shells. What do you guys want to do?
Shells.
Shells. So if I'm going to rotate around the axis to get a shell, I have to have a strip that is parallel to that axis, right? Okay. So rotating around the x-axis, I'm going to get a radius of y. I'll need everything in terms of y. So this is going to be x equals y plus 4 over 3. Comma y on that side. This one's going to be 2 comma y on this side. So the height of my shell will be the change in the x values. So that's going to be h equals y plus 4 over 3 minus 2. That's going to be my height. My radius is a y. So I will get the integral. I start getting these horizontal strips at 2. I end up getting the last one up at 8. I put in 2 pi, I put in r, I put in h. dy. So that would be my setup using shells to find the volume of rotation around the x-axis. We good with that?
Yeah.
The other easy one, now that we've got this, if we're going to still do shells, is like the line y equals 2. I'll rotate around the line y equals 2. The only thing that changes is my radius. My radius is not y anymore, it's y minus 2. Right? So I get rid of that and I put in a y minus 2, and that would give me my volume for rotation around the line y equals 2. See how like nothing with the setup changes except for the radius there when you change your axis of rotation?
Yeah.
So once we have one of these set up, if you find another axis of rotation that's parallel to the first, basically all you have to do is change your radius in the equation or the expression or the integral that you're setting up. If we want to do around the y-axis that switches, I either have to use disks disks with this strip, or hang on. Disks, if I was going to use this horizontal strip, or I'd have to draw a vertical strip in there to use shells again for a rotation around the y-axis or a rotation around the line x equals 7. Okay. Let's just keep this horizontal strip in there and try and rotate around x equals 7. So if I rotate around x equals 7, this strip rotates about the point 7 comma y. I'm still going to integral and have an integral from 2 to 8, but I've got disks this time with holes in the middle, washers actually. So pi, take the outer radius. The outer radius is 7 minus 2, which is 5 squared, minus the inner radius is 7 minus y plus 4 over 3. So that's the outer radius squared minus the inner radius squared. We see that set up.
I'm kind of confused about the inner radius one.
Okay, so if I draw in these washers, they kind of look like that, right? And the outer radius is the big radius, and that's the distance between this x value at 7 and this x value at 2. Because this point's at 2y, right? This point's at y plus 4 over 3 comma y. So to get my outer radius, that's 7 minus 2. That's this 7 minus this 2. The inner radius, well, it's still, this is the big x value, so it's still going to be 7, but then I'm going to have to take away the x value that's where the inside of the strip is. The x value there is y plus 4 over 3. So that's where you get your inner radius.
Okay, I see that now.
So yeah, it's all about the coordinates and which x values are you trying to find the distance between, which y values are you trying to find the distance between, that type of stuff when you're doing this geometry. So labeling these points is really kind of important. And when you're doing 4 problems on the same picture, it gets kind of messy, as you can see. So sometimes drawing the picture again might help. Any last questions? We're almost out of time here.
So if you rotate around the y-axis, how does that change it?
So your point here that you're rotating is going to be at 0 comma y. So let's get rid of a bunch of stuff here. Okay. So my washers look like this now. So there's my inner radius, there's my outer radius. So my outer radius, the big X coordinate is this one, the little X coordinate is 0. So R is going to be y plus 4 over 3 minus 0. But little r, that's going to be this and this. This is going to be 2 minus 0. So it'd be nice that I could like slide over and actually just draw stuff over here. Okay. So it's going to be the integral from 2 to 8 again. I'm going to have pi. I'm going to have my outer radius squared, which is y plus 4 over 3 squared minus the inner radius squared, which is going to be 2 squared. So that would be around the y-axis. That setup makes sense?
Yeah, thank you.
Okay. If you need an extension for the 6.2 stuff, let me know. Otherwise, I think we're going to start reviewing tomorrow. Come with questions over anything, and please do feel free to use any of the notes or the videos or anything like that that's out there. So use it if you want it. I'll see you guys tomorrow.
Can I ask you quick? Have you decided which days the tests are going to be on? Like, aren't they going to be split up into 2 different days?
Oh, which sections are on which days?
Yeah.
I haven't decided yet. If you guys want to think about how you'd like that broken up, we can talk about that tomorrow. To me, I think I'd put like 5 and 2 together and 3 and 4 together or something, and then figure out where we're putting 6. 6 probably goes with 5. But I'd try and put like an easy section and a hard section together, or kind of balance things that way, maybe.
Okay.
We can finalize that tomorrow. Anything else before I let you go? Okay, see you guys.